Hello everyone, and welcome back to the Fluctus channel. When seen on the horizon, a cargo ship may appear as a tiny dot. But up close, these ships are massive, like skyscrapers turned on their side, but with the ability to float. Container ships are designed specifically for transporting cargo across oceans. They were first introduced in 1956 with the maiden voyage of the Ideal X from Newark, New Jersey to Houston, Texas. Their load-bearing abilities quickly revolutionized the shipping industry. Typically constructed using steel, they range in size from small feeder vessels that carry just a few hundred containers to massive, ultra-large container vessels that can transport over 20,000 containers. Building these huge ships takes months and involves several stages. There is a crazy amount of power needed to move these massive and expensive container ships. After being designed by a shipbuilder, engineers cut steel plates and weld them together to form the hull, decks, and superstructure. Once the basic skeleton of the ship is in place, the engines, navigation equipment, and other systems are installed. The engines of these behemoths are complex, to say the least. The third largest container ship in the world, the MSC Tessa, uses a low-speed diesel engine. The assembly of this engine begins with the construction of the engine block, which is made up of several individual parts that are precision machined and then assembled into a single unit. Next, pistons are installed. Pistons are connected to the engine's crankshaft. They move up and down to generate power. Fuel and lubrication systems are also crucial components of the engine, as well as turbochargers and the air supply system. The turbochargers help to increase the engine's efficiency by compressing the air entering the engine, while the air supply system ensures that the engine has a constant supply of oxygen for combustion. Once the engine has been fully assembled, it undergoes extensive testing to ensure it meets safety and performance standards. This includes testing for emissions, fuel efficiency, and reliability. Any necessary adjustments are made before the engine is finally installed in the ship's engine room. In the case of the MSC Tessa, the engine has a maximum output of 98,000 horsepower and is capable of propelling the ship to speeds of up to 23 knots. This allows the ship to carry its massive cargo capacity of over 19,000 containers across the world's oceans in a highly efficient manner. Prices for container ships range from tens of millions to hundreds of millions of dollars, depending on their size and capabilities. The bigger the engine, and the more high-grade the steel, as well as the supporting systems and infrastructure, add to the complexity and cost of the ship. Visitors on a tour of a container ship's engine room would be immediately struck by the sheer size and complexity of the ship's engines. With that complexity comes incredible noise. The engines produce a constant rumbling sound, punctuated by the occasional blast of compressed air or the clanking of metal parts as they shift and move. The heat generated by the engines can also be intense, with temperatures often exceeding 100 degrees Fahrenheit. Despite all the noise and heat, the engine room is an organized and highly controlled environment. Engineers and technicians move efficiently around the space, carefully monitoring gauges and screens to ensure that everything is functioning correctly. The constant activity is mesmerizing, and visitors may feel a sense of awe at the complexity and power of the machinery around them. On August 18, 2020, the U.S. Coast Guard Cutter Healy, WAGB-20, suffered a fire in the ship's main propulsion motor while on a deployment to the Arctic. If something catches fire in the engine room, it can dismantle the entire ship's ability to move, which would be disastrous. Thankfully, flames were put out, and the Healy was floated to California for repair. The replacement part was across the country at a Coast Guard facility in Baltimore, Maryland. That spare motor was removed from the storage facility, craned onto a barge, and sent through the Panama Canal to the dry dock in California. Installation of the propulsion motor took approximately a month and required careful removal of the ship's dual hulls to complete. Propulsion units are the components that are responsible for generating the force that propels a ship through the water. They are typically located on the underside of the ship's hull and work together to create forward motion. There are several types of propulsion units that are commonly used in modern shipping, including water jets, pod drives, and even wind turbines. But the most common type of propulsion unit is the propeller. Propellers work by using the rotation of a set of blades to generate forward thrust. If they're damaged or outdated, the container ship doesn't always need to go to a dry dock. External replacement of propulsion units refers to the process of removing and replacing a ship's propulsion system while the vessel is still in the water. The process of external replacement begins with the removal of the old propulsion units, which can be a challenging and time-consuming task. The units are typically secured to the underside of the ship's hull, requiring specialized equipment to lift them out of position. Once the old units have been removed, the new propulsion units are brought in and carefully positioned and secured in place. One of the critical advantages of external replacement is that it allows the ship's propulsion system to be upgraded without requiring the vessel to be taken out of service. This means that the ship can continue to operate and generate revenue while the replacement work is being carried out. However, an external replacement can be a complex and expensive process, requiring specialized equipment and skilled technicians to ensure that the work is completed safely and efficiently. As concerns about climate change continue to grow, there is increasing pressure on the shipping industry to find more environmentally friendly ways of operating. One promising area of development is the use of liquefied natural gas, or LNG, as a fuel source for container ships. LNG is a cleaner burning fuel than traditional marine fuels, such as heavy fuel oil, sometimes referred to as HFO or diesel. LNG emits fewer greenhouse gases, sulfur oxides, and particulate matter, making it a more eco-friendly alternative. LNG-powered ships also generate less noise pollution, making them more attractive for use in ports and other environmentally sensitive areas. CMA CGM, one of the world's largest container shipping companies, has been at the forefront of the movement toward LNG-powered ships. In 2017, the company took delivery of the CMA CGM Jacques Sade, the world's first LNG-powered container ship. The vessel has a capacity of 23,000 20-foot equivalent units and is equipped with a dual fuel engine that can operate on both LNG and FHO. The construction of LNG-powered engines is a complex and challenging process. The engines must be designed to operate at extremely high pressures and temperatures, and they require specialized components, such as cryogenic tanks to store the LNG. However, the benefits of using LNG as a fuel source make the investment worthwhile for many shipping companies. Other eco-friendly technologies are also being developed for use in the shipping industry. These include hybrid electric systems, wind-assisted propulsion, and fuel cells. As these technologies continue to evolve and become more efficient, they will play an increasingly important role in helping the shipping industry to reduce its environmental impact. As the massive steel behemoths cut through the ocean, carrying countless goods and treasures from one corner of the world to another, container ships stand as a testament to the boundless possibilities of human ingenuity and engineering. We've discussed how their engines work, how they can be improved or replaced if they break, and the technological advancements to make container ships more environmentally friendly. In the future, we can expect hybrid electric systems, fuel cells, and wind-assisted propulsion to play an increasingly important role in reducing the carbon footprint of container shipping. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.